Hello, welcome to Module 2 of Week 2 of our course on Introduction to Dynamical Models in Biology. In the last module, I introduced you to JSim, a free software that you can use to simulate a ODE-based model. In that module, we have discussed the basic features of how to use JSim that has been discussed. In this module, I will take some example of ODE-based model and we will discuss how to write the code for that in JSim and then how to simulate that. So let us take a model first. Today, I will discuss a model on dynamics of fish in a tank. Suppose we are growing fish in a tank. Obviously, that tank has a capacity that how many fish can be held there. So that means the fishes are growing in a tank that has a carrying capacity. Let us call it K. Let us make another assumption that we want to sell the fish in market. So we are regularly removing the fishes from the tank at a fixed rate. And assume there is no death of the fish, lucky fishes. So I can write a ODE to represent the dynamics of the fish in the tank as given here. X is the size of the population of fish. So dx dt, rate in change in the population of fish, is equal to r into x into 1 minus x by k. You can recognize this first part is nothing but logistic growth model. So r is the rate constant for growth of the fish, k is the carrying capacity, and x is the population size. Minus d. D is the rate of removal of fish from tank and it is a constant rate. Now obviously you can analyze it analytically, but we want to solve this numerically using JSim. So how do I write the code in JSim for this model? I have written down the code on the right hand side. You can see and try to understand what each of these component means. Remember, JSim is a model. In JSim, a model has nested component. One nested into another. So in this model, the main component is fish model. It is the name of my model that I have given. You could give any other name. Now each component of a JSim model has particular type. For example, the model that we are doing is a mathematical model and its name I have given as fish model. So I will denote it as math type as shown here. So you have to write math so that JSim compiler can understand this is a mathematical model and it has to use all mathematical library functions that it has. Now fish model is the topmost component. It has many components listed here, nested under it. And everything nested under this fish model are within this curly brackets shown here. Don't miss this curly bracket, otherwise JSim will not understand where the model starts and where the model ends. Model starts with this curly bracket and ends with this curly model. So the key feature that shown in this slide is that you have to put a name. I have put a name fish model and you have to define the type. So it is math type and everything else is within this curly bracket. Let us look into the other component. Now in our model, t is the independent variable. So everything else, the dependent variable, changes in t domain. So we have to represent and tell JSim that t is a independent variable and that is done by this tag, that real domain. So I have written real domain t. That means JSim understand that t is the independent variable. Once you have told JSim the independent variable, then you have to tell it where it starts and where it ends. That means the minimum value of that independent variable and what is the maximum value of that independent variable that you have to say. So for us, time is the independent variable. Obviously time starts at 0. So t min is equal to 0. And t max, that is the maximum value, is 100. That I have decided. How time will change in between 0 to 100? It will change at a time step of 0.01 and that is shown as t dot delta. So what I have done here, I have defined t as a independent variable and marked it as a real domain. I have provided JSim the minimum value of t, that is 0. I have provided it the maximum value of t, that is 100. You can change it to some other value. And in fact, you can change this value later on also while doing the simulation. And you have to tell the increment in time, that is t delta, which I have defined at 0.01. You can change this value later on during simulation also. Note one important thing. All this information has ended with semicolon. This semicolon tells JSim that your instruction has ended. If you miss semicolon, there will be error in compilation. So don't miss them. Now we have defined the independent variable. So now we have to define the dependent variable. In our model, population of fish is only the dependent variable. So that is x, and I have defined it as x in bracket t. So JSim understand that x depends upon t, which I have defined here as a independent variable. And remember, I have written real before it, so it is a tag that represents that it is a real dependent variable. You can see these double hash marks. These marks are used to tell JSim that the words written after these are not instruction but annotation. Annotating your code is a good practice so that you can understand why you have written a particular instruction, and somebody else looking at your code can also understand what is the meaning and purpose of a particular code block. So annotation starts with these slashes, double slashes. Let's look into the other part. We have defined the dependent variable, independent variable. Now we have to define the parameters, the constant. Remember, our model has 3 constants or 3 parameters, r, k and d. Here I have defined r equal to 1, k equal to 100, d equal to 20. You can choose any other value depending on your purpose. And in fact, during the simulation also, you can change the values. Now these parameters are real valued. That's why term real is written in front of them. Let's look into other part. If you remember, every ODE solver has to know the initial condition. That is, what is the value of dependent variable at t equal to 0. How should I tell that information to JSim? That is what shown here. It is written as when t equal to t min. What is the value of t min? T min is 0. So that means this line instruction is telling when t equal to 0, value of x is equal to 45. That means I am telling there are 45 fishes in the tank at t equal to 0. Note that this value is within a curly bracket and I have a semicolon here. Don't miss these semicolons. So you have to define the initial value using this format. When t equal to t min, curly bracket start, x, that there is a dependent variable, is equal to some value, semicolon, close ups, curly bracket. The rest, what is left with us, is to define the ODE. Remember, the derivative of x is dx dt. That is represented by x colon t in JSim language. And as you remember, the equation is r into x into 1 minus x by k minus d. It is, as we have discussed earlier, ending with a semicolon. That's all. And JSim know your model. Once you have written it, compile it and run it. Let's see how I have done it in a video. So start by double clicking the JSim shortcut. We have to create a new project. Already once you have opened, a new project has opened. I have to add the model. So that means I have to go to add tool and add a new model. Put a good name. For example, here it is a fish model, so I put fish underscore model 1. So now a new tab has come. This is my fish model where I have to define the model. This is blank where I have to write down the model instructions. I have already written down in a text file so that I can easily copy and paste it. So I'll simply copy it from here and paste in this window provided in JSim for source code. Let us paste it here. So you have the code ready. Now I can compile it. Once you click compilation, keep a watch on the message tab. Here it is written in the message, it is terminated normally, and the runtime tab is active. That means my code is fine and it is compiled successfully. Don't forget to save it. Let us put a name for this project. So it is saved now. I will recommend you to frequently save your code. So I have a runtime tab from which I can control the run and I can edit the values of the parameters and any other values. You can see initial value, final value of t, delta t, everything there. Let us activate the plot page. We have to select a variable that we want to plot. Only one variable is there, that is x. X colon t is derivative, we don't want that. So we plot x in the vertical axis, t in the horizontal axis. Run it. Here you have your data. In the text tab, you have the text data, which you can save or export as a data file. I prefer saving it in C data, so you will write the name of the file, .cdata. Save it. Now in this model, you had only one variable, x, that is the population of the fish. But suppose you have more than one dependent variable. How to deal with that in JSim? Let us see. I have a model here with two dependent variables. And this is a classic model called predator-prey model. I have ecosystems like a jungle where there are prey and predators. Prey population grows by new birth and decreases as predator eat them. For example, you can consider prey as a deer and prey is deer and predator as the tiger. Prey population grow by itself, whereas the tiger go and eat the prey, so prey population decreases. As the predator eat prey, its population grow, and there is also death of the predator naturally. So how we will model this using ODE? We have some simple ODE-based model for that. X represent number of prey in the ecosystem, Y represent number of predator. So dx dt represent rate of change of prey in the population in the ecosystem. That is equal to k1x. K1 is the rate constant for growth of the prey population into the population at that time, minus k2xy. K2 is the rate constant for consumption of prey by predator. Obviously, prey and predator has to come in contact with each other. That's why x into y. Now remember, y is representing the predator population. So dy dt is the rate of change of that. It is equal to k2xy. This is a simplification. We have assumed that the predator population increases only as it eats the prey, the deer. Tiger is eating the deer. So these two values are same. These two terms are same. Predators are dying by natural death, so that has a fixed rate, k3 into y. K3 is the rate constant for death of predator. So I have two ODE, 1 and 2, and I have two dependent variable. So how should I code it in JSim? Here I have coded it. The first thing is math predator prey model. So name of my model is predator underscore prey underscore model, and I have told this is the top component and this is a math type. I have put everything else within this curly bracket, and then I have defined time as the independent variable, its minimum value, maximum value, and delta is defined. I have two dependent variables, x and y. Both of them depend upon time. So x in bracket t, y in bracket t, both of them are real. Here I have the parameters. You can choose different values and put different numbers. I have to define the initial values as usual. So at time t equal to t dot mean, that is t equal to 0, I have to define value of x and y both. So I consider initially I have 200 population for prey, that means 200 deer in the jungle maybe, and y is the predator, so I have 5 predator. Usually number of predator is always less than the number of prey. You can choose different value and you can change those value later on during simulation also. Now I am left with defining the ODEs. So I have to define 2 ODE, one for dx dt, one for dy dt. So x colon t, that is the dx dt, and you have the components here, k1 into x minus k2 into x into y. Second ODE is dy dt, that is written as y colon t, and then k2 x into y and minus k3 into y. That's all. We have defined 2 variables, 2 ODEs, and we are ready to simulate it. Let's see how it works. Again, I will double click and start JSim. I have to add the model. I will name it as a suitable corresponding name like predator prey. So I will go to the model source code page. I have already written down the code and I will paste that code on that empty space. So here I have the code. I copy and paste it there. Paste it, compile it. Notice the message is saying terminated normally. The runtime tab is ready. I save the file as a project. Note the extension of a project is .proj. I have saved it. Now I want to run and see how the system behave, that is x and y behave with time. So I want to plot it for different values of the parameters. So remember, I have to choose the model. I have only one model here, predator prey, but I have to choose variables. I have 2 dependent variables, x and y. You can see both are there. So I have chosen x in curve 1. I have chosen 2, and in curve 2 I am putting y. So x will be by black line and y will be by red line. Let us put name or label on the axis. The vertical one is population size, the horizontal one is time. So now run it. Here you got the data, both x and y, both predator and prey. One is in red, one is in black. You can see prey is starting for around 200. Then slowly with time it is increasing. Whereas the predator was initially at 5, it increases very slowly, and its prey, its population increases. As its population increases, population of prey drops. As prey drops, predators doesn't get any food, so their growth also drops. Then one predator drops, prey population get another chance to increase. So it keeps on increasing along this black line, and again by that time predator increases, prey population decreases. So what we get is the oscillation in population size of predator and prey. It's almost an infinite oscillation. I can save this data. I can see and save this data in text format from file, export data file option. Put a name. Don't forget to give the extension in the name, that is c data here. Save it. So you have saved the data. Remember, in our horizontal axis we have time, and in vertical axis we have population size for both x and y. This is by default. JSim will plot time, that is the independent variable, in the horizontal axis. But we can change that also. We can change and put something else in the horizontal axis. Let us do that. First remove the second curve by unchecking show. change the first curve from x to y. So we are plotting horizontal time, vertical is y only. Now you change the value of horizontal axis from time to x and press enter. So now you have a plot where in horizontal axis you have population of the prey, that is x. So write it down there. And the vertical axis will be population size of predator. Change that. So we have x in the horizontal, y in the vertical. You can see it is a closed loop as shown in the black line. Initially, population of prey is around 200, then as time increases, prey increases, predator increases slowly as prey decreases, and you come back to the original value of prey and predator, and you keep on circling in this closed loop. This type of plot is often called phage plot, where both the dependent variables are plotted together. So what we have learned in this module is that we have seen two different models. One is for fish tank model with one dependent variable. We have seen another model for predator prey with two dependent variables, and we have learned how to write down the code in JSim's own language and then compile it and run it to get the result and how to plot that result. So just to jot down the key point, JSim code has different components nested within each other that you have to remember. The key components of the model you should not forget is that time, that is the independent variable that you define as real domain T. You have to define the dependent variable like defined here as real xt and yt. You have to define the parameter values. Without parameter, numerical value of parameter, you cannot do numerical simulation. You have to define the initial condition. Without that initial condition, your numerical solution cannot be obtained. So it is done like this: when t equal to 0, that is t equal to t dot mean, at that time x is 200 and y is 5. This is the format by which you write and tell JSim this is the initial condition, and you define the ODE. And remember one key point: the main component is the name of the model that you choose and define that as a math type. Otherwise, JSim will not understand that it is a mathematical problem. Be careful about semicolon and curly bracket. These are the common mistake sometimes, very frequently we make, where we miss a semicolon in the right position and we miss the curly bracket in right position. Hope with this instruction you will be able to write your own JSim code and simulate it and enjoy. Thanks for watching. See you in the next module.